Hi students. So today we are going to discuss a topic on setting offsets with instruments. So this is from chain surveying. Objectives. On completion of this period, you would be able to know what is an offset. So in chain surveying, another instrument we are going to use, that is called offset. And what are the types of offsets? And procedure of taking an offset. So how you will use this offset in the site, where in the chain surveying. So once we recap, in the last classes videos we have seen that method of chaining on sloping ground by indirect method by using clinometer. So let us see offset. What is an offset? The lateral measurements taken along a chain line to locate the ground features such as buildings, boundaries, fences, roads, streams, etc. are called offsets. So what is the definition here? The lateral measurements which are taken along the chain line. That means, see here my diagram. So this is a chain line, okay? On the ground a chain line is there. So on this chain line, so we want to locate the a ground features or boundaries, okay? So while you are going in the chain line by taking, this is a chain measurement, okay? So this is the L. So nearby areas, any buildings or any uh, fences or any roads or streams are there. So from this we will be keeping here our offset rod, and we will be taking the measurement to that point. So that is called lateral measurement. So we are used in the buildings, whereas boundaries and fences and roads and streams. So these are taken to the right or left of chain line to such objects. So we can take either in the left condition or in the right condition, okay? So we can use this offset on the chain line whether as going on in the chain line to the left or right. Then these offsets are taken with metallic tape. So these offsets are taken with metallic tape. So we should use the metallic tape for the measurements, so that it will be convenient and correct measurements will be taken. So here, for taking the offset, following measurements are necessary. So we have to take the offset with the following measurements. So that is compulsory, we have to follow. That is, the first one is the distance of the point along the chain line from where the offset is taken, okay? So from the distance of the point along the chain line from where the offset is taken. So this is the chain line, and from the offset is kept here, from here the distance of the point we have to take. So this is known as the offset. And here the length of the offset from the chain line, the length of the offset must be from the chain line. And the offsets are called short when they are less than 15 meters in length. So when the offset length is only up to the 15 meters, okay, or less than 15 meters, so they are called as short offsets. So here the offsets are long when they are more than 15 meters in length. So that means now here more than by length of 15 meters, so it is called long. Okay, so in that the 15 is the number we have to remember. Okay, so the more less than or equal or greater than 15 meters, it is remembered as short and long. When the offsets are short, the perpendicular direction is judged by eye only. So within the 15 meters we can see the point very clearly. So that's why with our naked eye what we are seeing the point, we can give the direction and we can measure the length by the tape very accurately. So whereas when the offsets are long, okay, the right angle may be set out by means of a crossed-off optical square, etc. So suppose these offsets length is very long, so we will be taking the right angle. It may be set out by means of a crossed-off or optical square, etc. So how we will take this right angle with a crossed-off or optical square? Let us see. So here now we are having the types of offsets. So this is very important. The offsets are of two types. How many types are there? The offsets are of two types. So one is perpendicular offsets and the second one is oblique offsets. So remember, these names are very important. We are having the two offsets. One is perpendicular offsets and the second one is oblique offsets. So here the perpendicular offsets, this is the point. Let us see here. So the lateral measurements taken perpendicular to the chain line are called perpendicular offsets. So what is saying here? So as per the figure 1, you can see here this A and B is the chain line. Okay, so this is the chain line point A to B, and at the center of the A to B, at the center point we keep the C point. This is the offset we are keeping here. So while keeping this offset, so the rectangle, okay, the 90 degrees angle which is there, we will bisect to the D. So this point where we will get another point. So the measurement which is taken, this is called offset. Okay, the length of the perpendicular is called perpendicular offset. So this must be the 90 degrees. And these are also called right angle offsets. Okay, these are also called a right angle offsets. So these offsets are used for the making the right angles and taking the proper direction in between the chain lines so that we can identify the points and boundaries, any other fences are there, so we can keep this offset. And the next one is oblique offset. So let us see here, a diagram is given, that is A, B, D. So here the measurements which are not made at right angle to the survey line are called oblique offsets. So what is saying here? The measurements which are not yet made at right angle. So here we cannot see any right angle or perpendicular. So that's why it is called oblique offsets. And these are also called as tie line offsets. So we can see here, this is the chain line A, and here this is the point B. Okay, so these are the chain line. So the D point is our offset. So it is taking this angle and it is taking this angle. So there is no point here. So these are called oblique offsets. So now let us see the procedure of taking an offset. So in figure 3, so what is the figure 3 here? Let us see, go back. Figure 1, figure 2 is there. We don't have figure 3. So but let P be the object. I think so it is in the upcoming. Yes, this one. So this is the figure 3 diagram. So we can see a P point is given, and this is the chainage line. So let us see here in the figure 3, let P be object to be located. The assistance to surveyor will be holding the 0 end of the tape at P. So let P be object to be located. The assistant to surveyor will be holding the 0 end of the tape at P. Okay. So this is a P. At the end, the surveyor will be holding the tape, and the surveyor standing on the chain line with the tape in his hand swings the tape along the chain line. So that means here the surveyor standing on the chain line with the tape in his hand swings the tape along the chain line and records shortest distance as the length of the offset and is known as swing offset. So here the surveyor will be standing, this is the P point. So he will be keeping the tape, okay, catching here. This is the offset. So this is our chainage line which is there, okay, chainage line. So here with the offset length we will be taking the tape measurement and catching here, moving like this. So it touches the chainage line and it moves this side. So whenever the touching here, the point which is there, so that is the center of the point which is determined. So the moving process which is from to and fro, this is called swing offset. Next, number of offsets. So here offsets should be taken in the order of their chainages in the forward direction of chain line. So these offsets should be taken in the forward direction of chain line. So the number of offsets to be taken depends upon the nature of the object. So that means whatever the offsets we are taking, they will be depends upon the nature of the object. And as many number of offsets are required may be taken to locate outline of the object clearly and accurately. So here you can see offsets should be taken in the order of the chainages, okay, where the chainages lines are going on at the point only this in the forward direction chain line, these offsets should be taken, and this number of offsets taken depends upon the nature of the object. That means at the whatever the work is there, groundwork or any other related height work, so on the nature of the object only these offsets can be taken. And if as many number of offsets are required, so they should be taken to locate outline of the object clearly and accurately. So that is the number of offsets. And here you can see the example. If the object is round, an offset should be taken in the center only and its radius is measured. So that is nothing but here the object which is there, this one is the object, you can see. So the O, center of the O point is known as this is the object, and this is our chainage line. Okay, so from here, keeping the point at the center, we are taking the radius R, and this is the offset point which will be there. And if the object is hexagonal or octagonal, one of its sides nearer the chain line should be located by offsets and its length measured. So here if the object is hexagonal or octagonal, okay, whatever it may be, round or hexagonal or octagonal, so one of its sides nearer the chain line should be located by offsets and its length measured. So suppose you see how the hexagonal will be there, this is the hexagonal. So this is a hexagonal. So in this hexagonal, one of its sides, okay, by offsets. So at this center point, one of its sides means, so it will be located like this. At the chain line, they should be located by its offsets. So in between, we can keep the offset. If the boundary is straight, an offset to its each end is sufficient. But if long, a few additional offsets may be taken. So this is generally there. So if the boundary is straight, an offset to its each end is sufficient. But if it is long, more few additionals will be taken. So here the diagram is there. So this is AB is the chain edge length. Okay. So at this point, if we will be taking the offsets. So small a is a point is there from taken from the offset. So it is measured to the a dash, and from here, so from here the b dash, the another point is taken to the b, and this point is taken to the b dash. So like this, we will be taking the points cc dash, dd dash, and ee dash. So whenever the outline of the object changes direction, an offset should necessarily be taken at each change of direction. If the boundary is irregular, it is divided into a series of lengths each sensibly straight. So that means here, if the boundary is irregular only, it will be divided into a series of lengths. Suppose if the boundary is fair curve, such as railway line, offsets should be taken at regular intervals. So that means here boundary is irregular means like this. It is irregular like this. So in these places we can, it is divided into the series of lengths. Okay, we will be dividing the triangle or square. Okay, so by dividing these parts we will be taking the offsets. But if the boundary is fair, just like railway line or road, okay, so in these cases we can take the regular intervals. So this is the AB. Okay, AB, you can see this is a path which is going on. So A and B. So we can take the offsets on the chain edge line. So this black color point is known as chain edge line. So these are called offsets. So these are all called the offsets. So here, when the object such a fence, hedge, road, etc. crosses the chain line, the chain edge of the point of intersection must be noted. So this is generally in the chain edge of the point intersection must be noted. So whenever the fence or hedges or anything roads are there, so in that places we can take it. For locating corner of buildings, it is necessary to take offsets to the various corners of buildings and also the measurements of buildings. So here we can take, for locating corner of buildings, it is necessary to take offsets to the various corners of buildings and also the measurements of buildings. Okay, so in corner of the building, so you can see here, this is a building, so this is a corner, we have to measure here. So we will be taking from the offset length. So for taking this point, we can measure this length. So locating a building, how we will be locating it? Suppose this is the building on the chain edge line. Okay, so this is the A and this is the B. So this is a building is there. From this we can take the offset points. So offsets are used for the taken right angles, and oblique offsets are the taken in the triangle portions, etc. Let us see now. The next topic is instruments for setting right angles. So on completion of this period you will be able to know setting right angles with instruments, that is called crossstaff, optical square. So in the last period we have learned that what is an offset, types of offsets, and procedure of taking an offset. So let us see here what are the instruments for setting right angles. To set out right angle at a given point on the chain line, the following instruments are used. The first one is crossstaff, optical square. So what is right angle? You know. So on a chain line, this is a chain line. On this chain line we want to set the a line perpendicular. So this is called the right angle line. So what is crossstaff? How it will be? So the crossstaffs are of two types. One is open crossstaff and the second one is French crossstaff. Remember, very important. The first one is open crossstaff and French crossstaff. So open crossstaff, the open crossstaff is wooden piece in the shape of cross. Each arm of the cross has a sighting vane made of metal, wood or vulcanite. So this is called open crossstaff. So this open crossstaff will be having a wooden piece in the shape of cross. So the each arm of the cross has sighting vane. The sighting means in that point we have to see the object. So each of these sighting vanes is provided with a narrow vertical slit in the center of which is stretched a fine vertical wire. So here each of these sighting vanes is provided with a narrow vertical slit in the center of which is stretched a fine vertical wire. So this is our open crossstaff. Here you can see. So these are the sighting vanes. The points which are there, these are the sighting points which will be the gap will be there. So these crossstaff should be kept on the tripod stand. Okay, here you can see this is the stand type will be there and it fixed on the ground. Okay, so these are the wood material. So from this we will be seeing the object. So if you see from this object should be visible from this point, and if you see the object from this, and it should be visible from this point, so that if you are seeing any side from one side to another side, this should be visible the object. So this is a open crossstaff generally used for the setting right angles. The next, here the two wires opposite to each other give a line of sight. There are two lines of sight at right angles to each other. So that means here the two wires which are there opposite to each other, they will give a line of sight, and there are two lines of sight at right angles to each other. The instrument is fixed to the top of a vertical pole having an iron shoe at this bottom. So when the instrument at top, it will be having a vertical pole, so but at the bottom it will have an iron shoe, so that it will be fixed in the ground. So this is wooden crossstaff. So this is another category. So for this, at the bottom a iron rod will be there, so it will be fixed on the ground. At this is this under a threading will be there, so the in the threads it will be fixed, and whatever these lines are there, it will be a gap. Okay, in these lines a small gap will be there, so in this gap we will be sighting the object, whether from this side to this side, and either from this side to this side. Okay, so if the object is here, so we will be sighting the point. So suppose if the object is here, the ranging rod or anything, so we will be sighting the here, so that these points will be in the straight line. So that is nothing but we will make these points into the right angles. So it consists of wooden disc about 150 mm square and 35 mm thick. So it is of wooden disc of about 150 mm square and 35 mm thick. So this is called 150 mm. Okay, 150 mm square and 35 mm thickness. The disc has its on top surface two grooves cut with a saw at right angles to each other. So this line gap which is called, this is called groove. Okay, so it is cutted with both sides. This is a groove, and the grooves are about 10 mm deep. So these grooves are, they are 10 mm deep. 10 mm deep means this is a 10 mm deep. So the depth will be the, that means 1 centimeter. Okay, and the cross staff fixed to the top of a vertical pole are held in hand. So this cross staff is fixed at the top of a vertical pole are held in hand. So using of cross staff, how we will use this cross staff? Setting of perpendicular P on chain line AB. So here you can see the perpendicular, these are the points A and B. So P is the center point of AB, and then extending this line to P. So how we are extending this line? By keeping the cross staff here. So by keeping the cross staff the four sides, we will be seeing from here with our eye. Okay, so then within the grooves, the center point, the P point will be marked. So this is a object point which is marked on the ground with the help of cross staff. So this is nothing but the perpendicular offset. And the next is, the cross staff is held vertically at the point P with one pair of opposite slits directed to the ranging rods at A and B. So here the cross staff is held vertically at point P with one pair of opposite slits directed to the ranging rods at A and B. So looking through the other pair of slits, the surveyor directs the assistants to fix a ranging rod at P. So this is the ranging rod where we will be fixing at the point capital P. Thus the perpendicular is set out on AB at P. So this is the using of cross staff. Now let us see French cross staff. Now previously we have seen that is open cross staff. Now let us see French cross staff. So here this cross staff is an octagonal brass tube with slits on its 8 faces. So it has the 8 faces octagonal brass tube we will call. It has alternate vertical side slits and opposite to it is a window with horsehair on each of the four sides. So it has the alternate vertical side slits and opposite to it window with horsehair on each of the four sides. So the two adjacent lines makes an angle of 45 degrees. So in this French Falstaff we will have the two adjacent lines that they will making the 45 degrees. So with this it is possible to set the object at an angle of 45 degrees also. So here this French Falstaff we are using very rare in our surveying. So we prefer generally the open cross staff because it will be very easy to understand for everyone. But whereas this French cross staff it is of octagonal brass tube, so it is of 8 faces. So we can see this is the our French cross staff. So you can observe how many faces are there. So this is 1, 2, 3, 4. So again 1, 2, 3, 4. So this is rotating. It will be rotating with the slit. You can see in the cross staff we are having the gap. So in this gap we are sighting the object. So these type of cross staffs are very rarely used. So that's why we will call it as octagonal French cross staff. And the next one is optical square. So it is a compact pocket instrument used for setting out right angles. So this optical square is a compact pocket instrument used for setting out right angles. So this is totally, you can see totally off with the compact, and it is more accurate than cross staff. It is about 50 to 65 mm in diameter and 12.5 mm in depth. So this is the 50 to 65 mm diameter, and the depth will be the 12.5. So this is a optical square. So it is used for the setting of right angles also. Here a metal cover protects the instrument when not in use. So when not in use, a metal cover is protected here to the instrument. So the principle is a ray of light undergoes two successive reflections. So in this, a ray of light which will undergoes two successive reflections in a plane at right angle to each of the two plane mirrors. So here in a plane, that is in a one plane, a right angle to each other of the two plane mirrors, the angle between the incident ray and the reflected ray is twice the angle between the mirrors. So here the angle between the incident ray and the reflected ray is twice the angle between the mirrors. So in an optical square, as the angle between the mirrors is 45 degrees, the reflected ray is perpendicular to the incident ray. So this is the specialty of this optical square. So in this optical square, a angle between the mirror is 45 degrees. Okay. So if the reflected ray is perpendicular to the incident ray. So this is a using process. So here you can see a index glass, and this is the eye portion. So here this is called horizon glass. So where the and with the point over 45 degrees angle. So this is the actual plan we can see. So it will be closed and open, and from this is our eye place we have to see from this point. So from this point it will be visible to the B point. Okay, so when we see the object here, the index glass which will be there, it will be reflected here to the point. So there are small openings of about 1.5 mm dia marked E, F and C on the vertical sides of the box just opposite the eye hole E. So here this is the eye hole E. So there is a window F. The opening C is at right angles to the line joining E and F. So there are two mirrors marked H and I placed vertically above the base at inclined at 45 degrees to each. The mirror H, called horizon glass, is unsilvered at the bottom and silvered on the top, with silvered facing the opening E. So the horizon glass will be the unsilvered, and it is silvered at the top also. So when on the top is silver facing when the opening at E. So the mirror I, call the index glass, is fully silvered and opposite to the opening C. So where is the mirror I and C? Let us see here. So this is the mirror I. Okay. So opposite to the point, this B point will be the C. So from this totally it is with silvered. The horizon glass is fixed in position, whereas the index glass can be adjusted, so that this protected by cylindrical cover which slides over the box. So there is a small hole on the cover for inserting a key for adjusting the index glass. So let us see setting out the offset. For setting the offset at P, the optical square is held at eye level by the surveyor, who walks along the chain line AB till the ranging rod at P appears exactly above the ranging rod at B. It is noted that the ranging rod at B is sighted through the unsilvered portion of the horizon glass, whereas the ranging rod at P appears on the silvered portion after reflection. Setting out right angle. The optical square can also be used for setting out a perpendicular at a point P on the chain line AB. So the optical square is held with the center O over the point P. The line of sight is kept along AB. The assistant is asked to move the ranging rod P till it appears above the ranging rod at B. So what are the uses of optical square? This is used for taking offsets, especially when the offsets are more than 30 meters. So this is also used to set out a right angle at a given point. And this is useful for setting out right angles for taking measurements where there are obstacles in chaining and ranging. So finally, today we have seen in this period taking the offsets with crossed off optical square. So in the crossed off we have seen open crossed off and French crossed off. So generally we prefer in the side open crossed off. So this optical square is used very rare. In the such places only the optical square will be preferred. So nothing but the offsets are used for the right angles measurements. So taking the perpendicular offsets with right angles making the line on the chain edge line, whichever may be. So it will be useful to make the right angles within the short way. So these are the today's topics. So have a nice day. Thank you.